Hi, good morning, good afternoon, good evening. This is Davanum Srinivas. My nickname is Dims. I work for VMware, and I would like to welcome you all to the SIG Architecture intro and update. I would like to invite Derek to introduce himself. Hi, Derek.
Hey, Dims. I am Derek Carr. I work at Red Hat, and I'm excited to talk to you about what we do in SIG architecture and invite everyone to help participate and grow the project with us. Before we go too deep into what SIG architecture itself does and take a step back and look at what the goals of the Kubernetes project itself are, we are a container orchestration platform. And behind that core use case, we have some goals on wanting to ensure that what we build is portable, no matter where you consume Kubernetes, that it works as you'd expect, that the function we meet is general purpose or broad enough to meet a wide array of use cases, but not so specific to necessarily reject valid users of the platform to find value. And so we kind of work to meet users part way on their journey. And it might mean that some things are in the core of Kubernetes and then other use cases are better served outside the project. And so this is a balance and tension that all maintainers in the project are constantly working through. We strive to be flexible. There's a lot of interest in using Kubernetes in a wide variety of use cases. And so it's important that the project and the APIs and concepts we present enable that flexibility of use. And where the core project itself is unable to deliver the function that users may desire, we'd love to work with our contributing and user community to figure out points of future extension. In general, everything we do in Kubernetes, given the scale of the project, aspires to be automatable. So you'll hear about some of the work we do in this particular SIG to try to improve our ability to scale the project and the contributions to it. And then finally, Kubernetes is definitely not like a stagnant project. It's in my opinion, pretty cutting edge, advancing the state of the art of what you can do to manage software at scale. And so we want to always keep that goal in front of us to ensure that we are moving forward, meeting users' present and future needs. Our Kubernetes project goals are largely reinforced by the community values that we've been practicing for the last 6 or so years on ultimately making the community successful. And some of these goals are both, I would say, you can't overstate how important they are to the success of the project, both technically and on a human level. And so one of our most important goals is distribution is better than centralization. So some of the things you'll hear about in our role within SIG architecture is how we provide sufficient guidance and oversight across the project on best practices without necessarily acting as a blockade to progress in the various sub aspects of the project. In addition, a long-standing community value in the project is to ensure that the community is more important than any single product or company's goals. So what we do within SIG architecture is often trying to reinforce guidelines and practices to ensure that the community is meeting that need. As we talked about earlier, automation over process is important. We work with a volunteer army of contributors around the world who we always appreciate their time and energy in the project. And given what can happen with contributors coming and going over the life of a project, it's often important that we can codify their expertise at that point in time and automate as many practices as possible so we can continue to scale and meet the needs of our users and contributors. While Kubernetes is further along in its maturity curve than it was, say, a few years ago when the project was just starting, we continue to try to be an inclusive community. We invite users and contributors to give their feedback on what we should do better, what we're not yet doing to meet our needs. I think as we talk about the role of SIG architecture and areas for folks to help contribute, hopefully you'll learn that both Dims and myself are friendly individuals who look forward to working with everyone and bringing their feedback and helping the overall project be better. And so basically, never hesitate to make your voice heard. And then finally, the reason your voices are so important is it's important that the project doesn't stagnate, right? We want to always ensure that we're evolving, that we're meeting future needs that we might not have anticipated. And in general, we always try to steer our guiding principles towards evolving rather than just kind of stagnating on a status quo. So those community values are basically the backdrop by which the Kubernetes project operates. And so for those who might not understand as much about how the Kubernetes project functions, we're basically a set of what we call special interest groups that all kind of specialize within particular problem domains that the Kubernetes project tackles. And each of those individual domains, they can go between a horizontal and a vertical, right? So you might have people who are really deep in wanting to know how containers and the Linux kernel and isolation and security stuff work. And so you might find a home or interest in working within the node special interest group. Or you might be particularly interested in thinking about scheduling problems and how we can more effectively like bin pack workloads on clusters. And so the scheduling SIG would be a similar vertical segment. But a lot of people, when they interact with Kubernetes, are interacting with an API, right, a source of truth. And so we have some more horizontal SIGs that kind of build that foundational machinery. Things like API machinery, authentication, the end user tools you use, the CLI. So there's a lot of points of engagement that one can have that are very specific to domains, both vertically and horizontally. And so when we think about SIG architecture, we think about what we can do to provide guidance and oversight. So each one of these horizontal and vertical interest groups don't have to continue to relitigate or think through the same challenges or solve those challenges differently when expertise can be shared across the project. And so within the architecture SIG, we look to codify and document the principles and conventions that we follow, both in past and future decisions, to basically try to scale out best practices across the project. And so with that, I'll turn it over to Dims to talk about a little bit on how we do that.
Next slide, please. Okay, so talking about SIG architecture itself, we looked at how Kubernetes project is organized, but we do have some organization within the SIG architecture itself, and we try to figure out how we could do our day-to-day work and what do we need to concentrate on and things like that. So on the left-hand side, we are talking about how do we maintain and evolve the design principles, right? But on the other side, we also have to figure out how do we actually apply this on an ongoing basis with the incoming issues and PRs and stuff like that. So what we end up doing is we have a bunch of people working on some aspects of a SIG architecture. For example, the conformance definition, code organization, and API governance and stuff and things like that. So what we end up doing is we divide up the SIG architecture into multiple subprojects, and that's how we do our usual day-to-day work. Next slide, please. So what is in scope? The way it works is, Kubernetes is under CNCF. The steering committee is in charge of Kubernetes overall, but then SIG architecture is in charge of the scope of the project itself, the overall. So steering delegates to SIG architecture for that. So we are in charge of the conformance tests, API conventions, design principles, the enhancement process, deprecation policy, the whole gamut of things that keeps all the SIGs together in line and proceeding in a forward direction. Next slide, please. And how do we do this? We have a bunch of cross-cutting processes that we tend to set up. For example, the conformance subgroup ends up doing test reviews and then managing expectations around what tests get into conformance, and are the suite of tests enough? How do we make sure that we increase our test coverage for conformance, and things like that. For example, yesterday we were talking about like how do we have conformance profiles where we look at different aspects of conformance. For example, something that could be highly secure but not available across all the providers is one example of that. We also have an API review process. We rely on API review to help us a lot with backwards compatibility and things like that, as well as forward progress, like simple things like, okay, does the field have to be has to support like multiple things like IP addresses, right? Does it need to be a single field? Does it need to be multiple fields? Like, and what would be useful going forward and things like that. So API review, we have had a lot of experience over a time to evolve APIs. So the group run by Jordan helps figure out how to do API reviews and what to look for, and we try to write down all the things that we know as well. So similarly, we have a subproject that looks at enhancements and how do you introduce a new feature, what do you need to look for, and we have like a template which captures most of the things that we have to ask. So people who are just joining the project won't have to like turn to 10 different people, and each one of them has a different expectation of what needs to go into the enhancement proposal itself. So we have processes around that. Most importantly, we have processes around deprecation policy as well. So people can expect when things get deprecated and how things get removed. Next slide, please. So what other kinds of issues are there? It's mostly about like, there are so many resources that we have in Kubernetes, and not different people write different pieces of code. So how do we make sure that the behavior is the same and things like that? And there are always pitfalls in the process, and SIG architecture helps smoothen out or paper over things. And also anything that where there is a conflict between people from different SIGs. We are not meant to be like last court, Supreme Court or something like that. We mostly think about how do we make sure, what are the design principles that are involved here? How do we think through a specific problem is what we talk about in SIG architecture, and we turn around and set those design principles, and then those design principles help the SIGs take their decision. The objective is not for SIG architecture to make a call. The objective of the SIG architecture is to actually help the SIGs come to a decision point. So if you are in doubt, if you're in a SIG, you're working on something, what do you do? So you just start a mailing list thread, start writing a proposal with details, and then come to us for guidance if needed. Next slide, please. So I talked a little bit of each of the subprojects, but let's just go through the official list. So we have the architecture and API. They are responsible for the design principles, architectures, extension patterns. This is run by Jordan. We have code organization, which talks about repository structure, branching, vendoring, dependency management, Go modules, stuff like that, which is code organization that's run by me. The other one is conformance definition, where we are talking about, this is a little bit of a different animal here. So the conformance itself, from an end user point of view, is run by CNCF. So we work with the CNCF folks who actually run the trademark program as well within this subgroup. So this subproject is on our side. It's called Conformance Definition, and we review, approve changes to the test suite. And that test suite is in turn used by the trademark program to for people for the different providers to run against their own instances of Kubernetes, and then do a self-certification at that point. So Enhancements is a new subgroup. We used to have a SIG called SIG PM that was in charge of various things, and we ended up folding just the enhancements portion into a SIG architecture. We are also down this path of what are the things that we need to think about when a feature needs to, when we call a feature to be production ready. What are the things to look for there? And we try to insert questions into the enhancement process to get people to think about this. What kind of scale are we looking at? What kind of use cases that we need to support? How do we make sure that we don't break existing stuff? So a bunch of things go into the production readiness review itself. Let me hand over at this point to Derek. Derek?
Thanks, Tim. So Tim's provided a pretty good high-level overview of each of the sub-projects that are operated out of SIG architecture. So there are a lot of ways you can engage with the SIG. So we have a regular overarching SIG architecture meeting where we can talk about updates in any of these individual subtask activities that are happening. Or we have some dedicated forums that people can join to discuss the topics we'll talk about here. And that's typically what we talk to as sub-projects. And so you can focus where you choose to dive in and offer your time to the community. Or you can choose to engage with the SIG at a broader overview section to understand how each of the sub-projects are working. So let's talk a little about API review. Most users who interact with Kubernetes interact with the API directly, right? You are creating pods, you're creating persistent volumes, you're interacting with nodes. Kubernetes itself is a system of distributed components interacting around a centralized API. And so what's really important is when we talked about earlier, all the various SIGs who might be looking at things like scheduling or node or storage or networking, it's important that as an end user, nobody cares about which individual subgroup created that part of the project when they're consuming the project. It's important that there's a consistent design sensibilities and tastes that's applied so that the user experience for how the users consume the project makes sense no matter where the work was sourced. This was a process that was actually much easier early in the Kubernetes lifecycle when the project was much fewer API types. And we were able to lean on a lot of the deep expertise of some of our earliest contributors. And while those earliest contributors are still largely with the project today and trying to work hard to scale their time and expertise to help others, part of the goal of the API review subproject is to provide a formalized mechanism for new reviewers to both understand how changes can get made to the API safely, what conventions all API changes must follow, no matter where they are in the project, and kind of make sure that we have like a common standard of practice for how API changes are evaluated broadly, which is often extremely important in knowing how to evaluate something, even where reviewers may not have specific understanding of like the detailed section of that API. It's amazing how much the project depends on highly qualified API reviewers to keep us as successful as possible. And if individuals have an eye for detail and good user experience that want to help guide the future of Kubernetes API structures, I strongly encourage everyone to join this subproject and to learn. and hopefully offer your expertise for future contributors. The Kubernetes core API is largely, I don't want to say finished, but has matured. There's obviously use cases we've yet to satisfy within that core aspect of the API. A lot of the API review guidance and conventions that we follow in the project are focused on those APIs that come out of the project. So things that might be centered around pod or node or volume or those various resources. But the goal is that we can scale that expertise to provide guidance for third-party extenders to Kubernetes who want to follow our same general practices and guidelines. And so if you're looking to extend Kubernetes but want to extend it in a way that appears natural to users who understand the core, we strive in that subproject to help facilitate that future end state. Code organization, Tim's talked about this a little bit earlier, but this is actually a tricky area as the project has matured. So Kubernetes is written in Golang, and Golang has its unique approaches to managing dependencies. And all code that is shipped in a Kubernetes release is not necessarily sourced originally from a Kubernetes repo, right? We lean on the shoulders of others in open source who've provided libraries and utilities that we want to use to basically make Kubernetes what it is today. So things like runc or containerd or container runtimes or a number of cAdvisor, right? A number of libraries that Kubernetes traditionally would vendor into the code structure has definitely grown over time. And in the early phases of the project, I don't want to say that we were fast and loose with it necessarily, but we were less aware of the problems we were going to run into, both in how we consume dependencies and how others consume the project. So when you engage with the code organization subproject, you kind of look at the problem from both dimensions, right? How do we make it that when Kubernetes wants to take advantage of a new capability, one of the issues we've been talking about lately is just how to roll out secrets v2 maybe in Kubernetes support. And that might require changes in cAdvisor, in runc, in containerd, in cryo, et cetera. And you need to eventually get the kubelet to vendor all those dependencies appropriately where necessary, and not cause conflicts. And so there's this general issue of transitive dependency management that is tough. And so this could mean oftentimes when you want to make a new feature enhancement to Kubernetes, you run into obstacles on kind of getting all the necessary prerequisite work done in the sub-communities outside of Kubernetes that we depend on. And oftentimes, we are aspiring now in the Kubernetes project to make sure that we depend on fixed release versions of these external dependencies so that we can very easily understand when CVEs need to be fixed and that type of thing. We're not perfect on that everywhere right now, but it is a goal. And so it's an interesting process to work through to figure out how the Kubernetes project can continue to scale its code base while working on dependencies. Another major area around dependency management is around cloud provider integration. So a lot of the stuff as Kubernetes grew organically and tried to take on new infrastructure provider support, both in, say, storage and general infrastructure integration. If you want to integrate with Amazon or Google or VMware or any of the various infrastructure providers that might exist, often those libraries bring in additional backend dependencies that need to be kept up to date with the project. And so sometimes we look at dependency management from the perspective of how do we keep vendoring these things safely? And then other times we look at dependency management on how can we put the right carrots and stick in the project to make it that this work can be done outside of the core Kubernetes repo so that you can minimize the amount of dependencies and the sizes of the release that we need to take on to meet Kubernetes in a particular operating environment. So that's like, how do we as a coding community organize our dependencies to to produce an output. But then there's an inverse situation, which is many users now are depending on the Kubernetes API or various aspects of the machinery that we've written to help build their own applications. And so we have this general tension on, we don't want people to have to vendor all of Kubernetes, which is a significant amount of code, in order to just say use the Kubernetes API in their project. So we have a process that we go through to ask, how do we choose which aspects of code we make available for others to depend on? And how do we make them available in a small enough size that the projects that ultimately look to build and scale upon Kubernetes itself don't have to bring in all of our materials? And so things like Client Go, the Kubernetes API, the CRI, we're constantly looking at how we can take something out of our mono repo of Kubernetes and get it structured in a way that allows third parties to build on our tooling without needing to depend on the entire code. So if you're, in general, very interested in figuring out dependency management, both in the provider and consumer side, I'm sure DIMS would love to have you participate in the code organization subproject. Conformance tests and promotion. This is kind of the necessary follow-up to API review, right? Which is like, during the API review process, it's important that we look at it and say, will this work everywhere as expected? But in order to really verify that that is the case, you need to follow through on ensuring that things are tested. So we have a growing set of conformance tests within the Kubernetes project that get careful review to figure out if they should be labeled conformance or not. So of the hundreds and hundreds of what we call end-to-end tests that test various use cases across components in the system, for example, does quota enforce the amount of CPU access you need appropriately, or do config maps actually bind in your pods where you expect? A subset of those tests that test overall end-to-end function get elevated into what we call a conformance suite. And that conformance suite, to get a test integrated at that level, requires like a higher bar of review for a variety of reasons. One, that the original test as it was written might not have been written in a way that's obvious to readers of that test what it's really testing, right? So it takes some oversight to say, was this test written of a sufficient quality to understand if it should be a barrier to usage of the Kubernetes trademark in every operating environment, right? So ensuring that the test isn't flaky, ensuring that the actual function that the test tests is scoped and prescriptive. All these challenges and issues are what the conformance tests and promotion subproject focus on challenging themselves to help Kubernetes always get better and better. Then as features evolve in Kubernetes, they go through like a alpha, beta, stable GA status. And we have a general goal of trying to prioritize our conformance testing on things that have already graduated to what we call stable or GA. And then putting new barriers in place to ensure that for any new capabilities that come in, we are set up in the future to better conformance test those. Within this subproject, there's some really useful tooling that's been developed to kind of let you see what has or has not been covered under conformance. So there's an API Snoop tool that allows you to look within a particular API level, the core, if it's stable, beta, alpha, et cetera, what endpoints in that API are actually tested under conformance, so that if you take your application and you wrote it to run on your Raspberry Pi in your home office, and you wanted to transfer that application to go run with a particular distribution or managed service, conformance is intended to ensure you that application would work consistently in both environments. And so it's an ever-evolving process to get more APIs covered under the conformance suite. And the process by which to get new conformance tests is pretty well documented. Where we always could use help is providing that overview and follow through on the work. Enhancements. This is an interesting thing to talk through because at this point now, Kubernetes has grown so big, there's a lot of specialization. And a lot of users who first engage with the project will write some code and then say, this is a great idea, and then ping maintainers to say, hey, can you merge this? And so when we talk about the other aspects of the project around API review and overall evaluation on design conventions, enhancements kind of serve two purposes. One, like, how do we identify units of change that are large enough that either A, may impact the end user API, may impact how and when we choose to deprecate or take on new capabilities, or may impact more than one group. For example, like a change to the pod definition might be required in order to facilitate a use case desired in storage. So the enhancement process is meant to take leaders from the various special interest groups and provide a document or a design for us to rally on before executing on the work. So within the enhancement subproject, we try to build the standardized template that the project follows to make that process smooth and to ensure that things are seen to completion, not just getting it to an alpha state, but getting it all the way through GA. This is an ever-evolving process. Not all the work that was previously done in Kubernetes has a corresponding enhancement, but there is a goal as we go forward to make sure that every significant unit of change has a corresponding enhancement. So as a community, we have a record to follow. And as end users, you can work through and think, why were the decisions made as they were? So if you've contributed to Kubernetes in the past or look to contribute in the future and you want to help make this smoother, please help us join this subproject to improve our enhancement process. The production readiness reviews is kind of an evolution of that enhancement process. So examples that we were hearing back from cluster operators were oftentimes some features may have been coming out that we didn't really understand how to handle at scale, what things we recommended administrators to, say, monitor, or things that users who are either consuming a capability or providing a capability should keep their eye on in order to properly secure that feature, properly roll it out across cluster versions, or properly be able to identify if there were problems. And so this is kind of an evolution of our KEP process, where the KEP was originally focused on what is the change you want to make and over what set of releases will this change be made. And as the change is being developed, what were the milestones you're looking to meet in each scenario. And the production readiness review is more like asking yourself, do I have the right metrics around this feature or capability? So even if it's being developed in, let's say, the scheduling SIG, our instrumentation SIG can provide guidance on how to appropriately monitor that, as an example, right? In addition, like, there's a difference between the user documentation and the admin documentation. If you are rolling out a capability, for example, like seccomp, right? Something that might be very important to get properly handled in order to provide the overall security posture you're looking for. As an end user, you might think about, okay, I want to restrict the set of syscalls that my pod can use. But as a cluster provider, it's important that that is actually being rolled out as you expect. So there's a unique dimension between providing guidance on what security things cluster operators might need to understand and what monitoring things developers need to put around the code in order to show that the feature is actually successful. So if you have experience running Kubernetes in production and you think there's things we could be doing better to make features of higher stability when they come out, we'd love to hear your feedback in that subproject. And with that, I will hand it back to Dims.
Derek, let's skip this slide. This was an old deck. Okay, so one important thing, maybe I'll bring you back, Derek, as well. So one fun thing that we've always been talked about is Kubernetes is a platform for building platforms. What does this really mean, Derek?
Yeah. So Dims, Kubernetes has a job API, and my company or my customer or my user, they just they got this really important use case, right? And Kubernetes kind of solves it, but doesn't solve it all the way. And so, I'm really interested in building a new type of variant on job. I think it's going to be widely useful, but I just want to get it in the core right now and provide value to my users and company. Can I do that? What should I do here?
Absolutely. So this is a question we get all the time, Derek. Thank you for asking that question. So the way we approach this is we first our first instinct is not to actually write new code and include it in Kubernetes core itself. What we try to do is we try to give a place where you can do this experimentation, where you can prove out the concepts. And we think about are there extension points where we can actually try to help you do this yourself and get a body of people to adopt your work. There's been so many different features that we ended up doing outside and then bringing it into Kubernetes. And there is also things that we have talked about where things that are in Kubernetes, we try to move out to external projects as well. So let's explore a little bit of the extension points. Do you want to go to the next slide, please?
Yep.
I think we skipped one. We can go back one. Okay, so what we try to think about is how do we avoid bottlenecks? For example, if you have to make a call to an external system, then how do we make sure that Kubernetes itself doesn't come to a halt, right? How do we increase the supported use cases? How do we let people rapidly iterate and not have to wait for a release of Kubernetes? How do we make sure that we allow people to experiment, capture best practices, and provide, and what we end up doing in the end is provide guardrails over integration. What does this mean? This is all abstract stuff. So let's go to the next slide and we look at a few examples.
Actually, if it's okay, Dims, if I think about the example I had, my client, my customer, my user, they need this capability in the next 3 to 6 months, right? What can I do here, right? Are you saying basically I should be doing this work out of tree, improving it myself before trying to take on a 12 to 15 month process to get it into Kubernetes?
That's definitely one option. What we would try to do is see if there is an extension point already. If there is an extension point, does it? Are you able to do the work that you need to do using the extension points? And we have a lot of examples of the extension points. So if you want to take the job one, right? So can we use a CRD to implement or at least design the variant of the job that you're talking about, Derek? And then are there enough extensions elsewhere to be able to use the thing that you're talking about? Can you write a new controller? Do you actually need, there's multiple variations, right? Do you need to do API aggregation or do you need to do CRDs? So we have a few choices there as well. So let me turn this around to you, Derek, and see which ones have you actually tried outside of Kubernetes main project here?
Yeah, so my job API, it's mission critical. It's what's paying people's paychecks. So my company is and my users are really expecting that I have strong validation on that code, right? So I've tried third-party resources earlier in the life of Kubernetes. Now I hear about these custom resource definitions. That looks like the right thing. I think with admission control extension and webhooks, I can provide validation on my schema. We talked a little bit about the client Go and the APIs I can use to interact with stuff. So I think I could probably hack something together. So at least from what I see here, I feel like I probably could meet my use case out of the core project and still be successful in the timeline and see if there's value there.
Don't forget the kubectl extensions. That's like a new thing where you can provide your end users with something tweaked, which works for your environment or for your new job type. So that's definitely.
I'm definitely going to have to interact with this resource. So being able to have it pretty printed and described and all that looks like that's something I should look in a little more detail. But yeah, it looks like for this particular use case, Kubernetes shouldn't be a blocker for me. I can get value outside of the core project.
Nice. Glad to hear that, Derek. Thank you. So let's go to the next slide, please. So where are we going? We want to let the ecosystem grow, distill the new patterns. We want to build out the conformance. We want to clean up reliability and we, make things more reliable. We also want to make sure that the features that we have that are in alpha go to beta, things that are in beta go to GA, and we are trying to put together a set of processes to make sure that we force the features to go GA quickly. And we have to solidly go behind keps, and make sure that we write things down earlier in the cycle so we can think through a lot of these things and not do a knee-jerk react later at the end. So next slide, please. So how can you participate in all these things? So we have like a main project meeting for SIG architecture, and we also have sub-project meetings. So come hang out with us. You don't even have to talk. If you come there, you can be a fly on the wall. That's how all of us started, So come be a fly on the wall, listen to all the things that we're talking about, and then soon you'll get the hang of it, and you will come out of your comfort zone and start talking to us. Use all the asynchronous stuff that we do, project boards, mailing lists, Slack. Speak up, please. We are a welcoming bunch, and we just want to see you a few times, and we'll actually give you stuff to do. So don't hesitate to speak up, or just take meeting notes. That's usually a big help. We'll walk you through issue triage, PR reviews, docs, and things like that as well, if you have some interest and if you have some time. So to wrap things up, next slide, please. So thank you for attending this session, and let's open up the lines for some Q&A.
Thank you.
Thanks. Hi everyone. Hi Derek.
Yeah,
it looks like
you can hear me now, Dan.
How are you feeling, Derek? Good?
I got that job API written, feeling good, hoping to get in the core Kubernetes soon.
Nice. Best of luck to you. So I think we are almost out of time since we ran over a little bit. So many thanks to Theo and Brittany for running the session for us. And we've got a good set of questions going on in Slack, so we'll hang out with you there. So any last words, Derek?
No, thanks again for those joining, and we'll answer any questions in the Slack.
Hope to see you soon. Bye.